A random sample of 12 values is taken from a normally distributed population, resulted in the following sample. Use the sample information to construct a 95% confidence interval estimate for the population mean. And remember, when you are making confidence interval for the mean, you use t-stats. And this one is with data, so you copy the data. You need 95% confidence. Okay, so let's try it again. So you would do stats, t-stats, one sample with data. Select the column, select the confidence, it was 95%. And so it's 98.3 to 106.7. $98.32, 106.68. %90 confidence interval. Okay, they have a part B here also, so let's do it again. First part is nothing, just 90% confidence, and it's for the means again. And the reason I keep saying it is that right now, okay, you are seeing this title that it's population means because we are doing this section. But once these problems appear in the exams, then you will have to spot that since they're asking the confidence interval for the mean, so you have to use t-stats and not proportion stats. So this one was stats, t-stats, one sample with data. Select the column, and this one they were saying 90% confidence, so 0.9. So 2.486, 6.114. 2.486, 6.11. Okay, show that what impact would be if the confidence level is increased to 98%. Okay, so now you change the confidence to 98. So we can do options, add it, and change this to 0.98 here. And so now the interval is 1.51 to 7.09. 1.51 to 7.09. That's a wider interval. Because margin of error is greater for a higher level. So 1.51 to 7.09. And why is it wider? Because the original one started at 2.5 and finished at 6.1. So this one starts earlier. It starts at 1.5 and it finishes later. So in fact, it starts earlier, finishes later, so it's wider at both ends. It's a bigger length of interval than this one. And the reason is that the margin of error is greater with higher confidence. Okay. So same here. Let's construct the confidence. Oh, okay. These are two problems here. So let's go back. So they say first construct a 95% confidence interval for the mean pulse rate of males. So the first part is about the males. So 95% interval for males. So what you will do is when you do the stats and t-stats, one sample with data, you only select the male column. And 95% compute. So 69.49, 88.91. Sixty-nine point five, 88.9. And now you have to do it for females. So you do options, edit, and now select the female column. 80.5 to 103.5. 80.5. Okay, compare the results. Can we conclude that the population means for males and females are different? So once again, let's review our understanding of confidence intervals. So it's telling us that for the males, the pulse rate will be somewhere between 69.5 and 88.9. And for the females, it will be somewhere between 80.5 and 103.5. Now, at first sight, it looks that they are different, but if you notice carefully, there is some overlap. So, for example, the value of 81 falls in this interval and also in this interval. So as long as there is overlap between the two intervals, there is a possibility that because the rate, the actual value is most likely somewhere here, and it's one value which is somewhere here. Similarly, for the females, it's one value which is somewhere here. So as long as the two intervals have some overlap, it is possible that their rates may be, the pulse rates may be the same. They will be different only if these two intervals are completely different with no overlaps at all. So in this case, we cannot conclude that they are different. No, because the two confidence intervals overlap, so we cannot conclude that the two population means are different.